recording was not going on. Okay, now it is recording. So just to keep in the video, the exam is part 2. It comprises all 6 lectures on envelopes, including today's review, of course. It is tomorrow, 23rd, 10:30 starts. Blackboard, and the same system as in part 1. I explained why the system is as it is, right? It is not perfectly convenient, but it is all we can do to make a reasonable exam, preventing or at least reducing the chances of cheating. And it is tomorrow, don't forget. Please wake up on time. Have some friend or somebody at home to wake you up if you don't hear the alarm bell and so on. But please be ready for tomorrow. So it starts at 10:30, and you have exactly 5 minutes to log in, right, to start it. After, when the clock reaches 10:35, it's already late. So be sure you log in as soon as possible. 5 minutes is more than enough, and it gives you a margin to go in. Actually, for the everyday test we do for attendance, just 2 minutes is usually enough. But I understand the test is a bit more stressful, so you will have a bit more margin. The test will be about 20 questions. Actually, I'm still preparing it, and it will be calculated at about 1 minute per question. You will have to reply the questions as they appear. You will not have the opportunity to go back, so please understand the question, think carefully, and make your choice. I will try the questions to be short and clear. That's not always possible, and sometimes a bit more confusing than I expect, but through the years, I have been shortening and unshortening the test. 20 questions, about 1 minute per question. Good question. 30 minutes. Somebody was asking about 30 minutes this time. Did we do 30 minutes last time? Okay, so I may think about, it depends on the difficulty and the complexity of the questions. So it will be between 20 and 30 minutes, okay? Let me think about it. But the question is to have enough time, but not too much time. You can use reference materials, of course, as you wish, but please remember that whatever is in your brain is the fastest. So you may look for specific data, names, words, whatever. So you have to organize your information. But if you have one question and go to Google and Naver to find what is it about, you might not have time to make the exam, right? So it is why the basic understanding is important. And then, of course, I cannot control it, but you should do it individually. That depends on your own responsibility and your own sense of how to do things in the right way. So it will start at 10:30 again, and the lecture will start at 11:10. We have a short lecture in which we will introduce the rest of the matter, and we will also introduce the next set of assignments. So we will start already with your own project, but we will explain that tomorrow after the exam. And well, even though today is a bit early, I think it is a good chance to do our initial test. Nobody is waiting to enter, so please go into Blackboard and start now. So it's open, right? And it's one very easy question. You will do perfectly fast and accurate. Let's wait a little bit to see if somebody comes in. Well, Junu, I think you should go back to the handouts of the previous lectures and check about the exam date. Everybody else has perfectly understood, right? So let me check again. I think 2 people started now, but except for one, everybody knows about the exam date. Okay, so let's continue. The exam will be closed now. So those who didn't do it will be almost late or really late. Okay, let's continue with the class because nobody came in between. Let's go into the questions and answers, and we will start. Okay. Well, having the question wrong or right is not a problem. What I'm worried is that somebody does not know yet about the exam date. I'm replying to the chat question. But wrong or right, you have your attendance and your timing, so there's no problem. So the first question is about the plinth detail. Curiously, it's one detail we explained twice this course, and it was a revision from the basics we saw in materials, but still it seems complex to understand. So let me go into it. The first was about the terminology, the words. Actually, English is a foreign language for all, including me. So it has this trick. So the question is, what is the difference between waterproof, watertight, damp-proof? Because you will hear like places of against the damp, right? And you have also damp-proof in the book. You have a water tightness and so on. So to try to be clear, I usually choose to speak of waterproof, only one word. So waterproof just means whatever prevents the water to cross it. Well, one layer, one element in which the water cannot go through, right? That's waterproof, the idea of waterproof. Watertight is more specific, and it usually refers to an assembly, right? Like a joints, seams, overlaps, or elements which like a full system, like a windows, facades, roof. So it involves elements which have joints, right? And those joints, those elements are made in a way that the water cannot go through the joints and of course through the elements. And that is the idea of watertight. You will hear also airtight. That is the same concept. The air cannot go through the joints, the slits. Usually you will not expect the air to go through concrete or brick, but usually through the slits or to the cracks. So that's the idea of tightness. And the damp-proof, I never use it because actually it is the difference between water and damp. Water is just a mass of water, right? The damp is like a particles of water or drops or sprays, something which is infiltrated, like the tap on the air. It's particles of water in the air, not like a really continuous solid, not solid because it's liquid water, or the water in the pores of one material, and this is what we call dampness. This is very British, right? Very English. And this is why when they speak of the capillarity, they're speaking about damp, because it's not really physically a mass of water moving around. It's just the particles or small drops or small elements. So in general, myself, as a foreign speaker, I try to simplify and use waterproof for everything, right? But well, there's a small difference between those terms. One more question about these porous boards which appear in the book, right? So why I speak of a drainage layer, the book speaks about gravel, porous boards, and other elements. So the question is that the drainage layer is whatever layer we put to let the water go down. And usually to define it is to have enough open space, like air, right? So the water will not stick. So you have the drops of water, and they have not a space for them to stick into the wall, so it will fall down. So this is the wall. This is whatever device we have to separate the ground from the wall. So you have just a void air in between. Whatever water goes through will just drip down. If that element is very thin, let me change the graphics to make the same. If we make a very thin layer, the water will go through, but will keep sticking by capillarity, right? That's the source of tension, so it will not work. So that drainage, what makes is gaps big enough to, okay, somebody calling in. Just one moment. Okay, so I let you in because it was you alone, but from today on, as I announced, I will open the door of the class just 3 or 4 times. So you would have to wait if you're late until I open, so I don't need to stop as I'm doing now. Okay, so the question is the drainage just makes the gaps and be one full layer or be spaces between the gravel elements, so the water will just slide down, will not stick. So the water will fall down by gravity. That's the concept of drainage layer. And one way of achieving it is by using a layer of porous boards. So if there's not solid porous, the water will enter, but it will slide down just by gravity. What is the problem with the porous boards? Well, that's a bit ambiguous, in my opinion, because those pores can be that porosity, what was I going to say, can be too thin, so the water actually will remain there. So these ports should have the openings big enough so the water will always slide down. And this is why I prefer to use a different term, right? And there are many different solutions. So I brought some examples. This is what we saw in materials, and this is very clear. This is a section of sloped land in which we expect the water sliding down. So what they do before the basement wall is just a full, huge pipe with holes from which the water will slide. Actually, the water will be retained and it will try to go out through the easy way, and it will be collected and go down. So that is like the extreme case of that drainage layer. This is traditional. This is taken from the Italian standards, 1950s, in which you see the gravel, and it's in purpose drawn big enough so every particle of water, drop of water, which may accumulate, will just slide down among the stones. And they don't even have that drainage pipe. Yeah, it depends on the circumstances. Of course, the floor will prevent that drainage, so we expect to have very small amount of water going there. See how in these all details you have this asphalt. Well, asphalto means asphalt, right? And even second cutting point on top of the foundation. See also that drainage layer under the floor of the basement with another waterproof layer. And very sensible to have ventilation So whatever dampness, whatever humidity can happen in the basement will be dried because the air moving. The element you see in the lower part is touching the ground. So you have like a continuous impervious. Impervious means that it doesn't let the water go through elements, which are, if you read, resistant to water. This can be stone or some kind of mortar with some paint, which will resist this kind of water aggression. This, of course, is not what we do today, but it's one of the sources we have, right? It's like a traditional construction. And today we try to be more simple. So actually gravel is complicated, expensive. You need to have a lot of space. So one very popular is what we call the delta membrane. There's many patents and you can find almost everywhere, which is, I think it's polyethylene layer with this kind of elements, which have a stuck one felt, right? So the water will go through this felt and will slide down because you have probably like a 20 millimeters, right? Which is enough for the water to slide down. They are bigger or smaller, but usually it's about 20 millimeters. You see the size of the hand. So this is the waterproof layer, and this is the drainage layer put vertically. In this case, the felt is black. In this case, the felt is white. And here, just the refill is just going straight against it. This is one photo I showed before. This is one of my constructions in which you can see the polyethylene and the felt. So you can see that small thickness, which will make the water just slide down. And additionally, there's another layer of gravel. This is not exactly how the book shows. And you will have always different ways of doing it, right? So the book just gives you a standard and you will see other ways of doing, and through the experience you test and you change depending on the performance and the circumstances of each construction. But obviously gravel you have to buy in huge amounts, in huge volumes. So you will try to use as little of materials as you can. Although I cannot say this polyethylene and this fiberglass is especially ecologic. But yet, if that stays forever in the building, it has a long life, and maybe it's not a big issue. And I think that were most of the questions I had. They were all related to the plinth, right? And the drainage and the waterproof. Other questions, I will go through previous years. This is a small collection. I will try not to be too long today, but I don't know how long we may take. So, but anyhow, we will finish on time. So I will try to go fast because there are many questions. Some of them are more interesting than others. So why some insulation materials cannot get wet? So the problem with insulation materials is that many fiber materials, like the mats, right, are porous, so they can absorb water. And if they get full of water, the insulation power really diminishes. So most used for waterproof insulations are closed cell. So there are foams that are fabricated with like closed bubbles. So they have the insulation power, but the water cannot go in, right? So the water will just slide and go out. If you have fibers, the water will just slide in and you have a damp, wet insulation, which will not really work. So that's the point. So this is just closed cells with air. And so the water will always slide around. What is the problem? I didn't write it here, but the problem is that polymers burn. So many codes just forbid them in many cases. That's not the case of Korea, but many codes forbid to have a polystyrene in one roof or one facade. So how can we have that kind of inverted roof in that case? There are makers that have this kind of fiber elements, right? Which is kind of a coating or some kind of resin which makes them waterproof, right? So this is, well, this is kind of old material, but the industry has to adapt to new needs. And we know that the polymers burning is a huge problem. We have very recent cases, even here in Korea, in which facades burn just because of the flammable insulation used in the walls. So we have to avoid it. That's an important question. Second question, we said, and this is exam question, so careful about this, that in curtain walls, yeah, CW is abbreviation for curtain wall. Remember that we have aluminum, mullion, and steel, which is basically iron with other materials. They cannot touch, so we put some space in between to avoid a galvanic pair, right? If you go to the lecture or you go back to materials, we know that iron, steel, actual steel is not iron, it's an alloy, but okay, steel is more noble than aluminum. So aluminum will lose the electrons towards the steel and the aluminum will corrode. And eventually those bolts will loosen and the material can go out. So we avoid that, but put in a separation in between. The material used is anything which is thin, strong, flexible, waterproof, and durable. And for what I asked the experts, so I did a question to the consultants of facade, they usually use PVC or polyethylene. There are many qualities and many varieties of PVC. So some material which is quite durable and resistant to heat because it will have sunshine and hot temperatures in summer and very cold temperatures in winter. So it should be one material which is treated to work in those extreme environments. Another question is about the detail we saw often in the book. Why separating the wall from the facade? You may remember, because we spoke often, this is a concrete, actually this is a window, but this is a structural wall, structural concrete floor, and there's a gap in between, which is quite unusual because we're used of the advantage of concrete to be monolithic, right? Mono means one, and lithic means a stone. So that means that being of one piece. This is one of the big advantages of concrete, right? So we make floors and the walls and they all stick together solidly. So why are we going to break that advantage? And again, that's because of the trend to zero energy, right? To be very, very efficient, to have the maximum of insulation. So that's the only way, or one of the ways I would say, to have a continuity of insulation without thermal breaches, and that makes a big difference in performance. More questions, right? Why the roof slope design is asymmetrical? Remember that we say that we have a flat roof, we divide it into bits, and then we find the point of the drainage points, and we make like a small inverted pyramids to make the water go into those points. So you have a slope in those areas and they go to the drainage point. So why many points are asymmetrical? I think we commented in the lecture, but usually it is because under the roof, you will have beams, right? You will have walls, you have elements that you want to avoid. And of course you want the pipes to go to a convenient place. So usually you place them in a place which will not interact with the structure or with walls, and which will make a minimum distance to a possible vertical pipe. So this is why integration is important. And you have to know at least structure, so you don't have a pipe in the middle of a column, and also with partitions, right? So whatever is designing the roof, we'll have to see how much space they have to make those horizontal connections, where to put the vertical pipes without having a conflict with the rest of the distribution of the building. And another question, which is the best slope? So how much we have to make this slope to the drainage point, right? And that's an interesting question because there's not a perfect reply. Usually we have a minimum 1.5%. If you to very small slope like this 1%, it may happen that small irregularities may have the water causing ponds because construction is not perfect, right? So to avoid it, we go usually 1.5 to 2%. All the guys try to make as much slope as possible. That means less time the water in the roof and less chances for leaking. And if we go over 10%, it's already almost a sloped roof. So we really feel like not really flat. Also, well, the limit is conventional, right? You may have the flat roof, the asphalt protection even in a 45 degrees roof. But you will have a difficulty to protect it with anything. You would have to fix it. So usually the conventional we say is about 10%, like 7, 8 degrees. But I seldom did more than 5%. And it looks ugly. So if you have many bumps, the element doesn't look nice. More comments, the pipes, this is about a roof drainage, right? And it's about the pipes in the facade, how they connect. Actually, they connect. There are many ways to connect. Going under the floor or even going through the walls, right? There's many ways to do it. And you will see an example. This is taken in Scotland, I think it's Edinburgh, in which you see the pipes coming from the roof, and often the pipes from well, other parts, right? This is to inspect. So like a cover, you can open, you can connect, of course, new elements. So you can see everything is in the facade. And this is probably one bath connecting to that line. And this top is the ventilation. So the water would flow without having making voids. So the question is always how to connect those elements to the facade. Of course, the problem with elements in the facade is that they are ugly and you have to plan for them, but they are safer. And no wonder in a place like Scotland, when it rains almost every other day and the days in between, they are very safe and they have the pipes outside, so you can maintain and you can adjust, you can repair. And you can see even here probably one kitchen drainage going to the sides, right? So everything is on the exterior and the leaks in the building are minimum. Usually we'll try to make it inside, right? But then you have the problem that are hidden and you have to break things, and finding leaks is more difficult. So this is always a choice of design and the need of maintenance you may preview. Other question is about the fixtures of a curtain wall anchored into concrete. So we see that the fixtures are really anchored. This is one element which is precast, which is the best solution. So you prepare the concrete with all the rebars and you put your connection elements with some kind of anchoring, and then you pour the concrete. And this element, which is the rail, you see, is perfectly fixed, and it is very safe and very much very solid. But usually fixtures are often done in a different way. They are just drilled into the concrete, right, with a driller, and then you put some kind of a fixture element which will tighten when you put the screw inside. They will tighten, and it is very safe also, but it works on pressure. So you need a minimum distance to the borders. So the concrete resists this tension. Otherwise, if this is too small, the concrete may crack and it will not be effective. That is very well explained by the makers, and the engineers usually take care of it. This is why we have always at least 5 to 10 centimeters. It depends on the strength of the anchors. And some anchors are chemical. That means they don't create so much tension on the concrete, and you have a bit more margin if you don't have much space. So that's the case of the drilling, right? Then the difference between a spandrel and mullion, I think it's again language, and if they are timber sashes, well, the spandrel is the space between two windows, right? And the spandrel word is the same in Korean. I think Korean, even Japanese, adopted the English word for the space between windows, which usually will also cross with the floor, right? With one floor. The mullions are in curtain walls. If we have one floor, right, are the vertical elements which will be fixed to the slab, over which we will fix the glass. So the concept is very different, right? So this is the vertical, this is facade, a structural element of the proper facade. I think it's mostly linguistic, but just in case. How can we put glass to the curtain wall without silicone? So we said that actually we have a structural silicone, which is probably one of the few choices to make the flush or flush glazing. That glazing in which you have the mullion, right? And the glass is just put to the exterior without any kind of element outside. In that case, structural silicone, and we said also the strong two-sided tape. If you go to the lecture, we spoke of those fabrications. We depend on that kind of a sticking element, on that adhesive, right, of the glass. And there's not much choice in that case. But in every other case, just neoprene or similar, right? Because neoprene is the traditional material, but you have so many polymers around that I cannot choose only one. Or this was similar or better gaskets. Right. This is safer. They work by pressure, and they are long-lasting, and they are standard. They're fabricated, so you can keep a very good control of the construction and a very much precise construction. The problem with this silicone, this is applied by hand, and depends very much on the ability and the consistency of the worker. And that's always a problem in construction, because it's not one worker making one window. It is like kilometers of joints in one building made by different workers, and their ability and their way of doing may be different, and their precision may become worse at the end of the day when we're more tired. They can be distracted, and things may happen, right? Whereas the gasket is industrially made, is precise, and it has really no possibility of so many errors. This is why silicone, unless you choose one system which relies on it, is a second choice after good quality neoprene gaskets. Again, cracks in the science library, I think it's very small, but we said if we have a rigid parapet, right, over a flat roof, you remember that flat roof has a slope formation, has a flooring, whatever. Those elements will be subject to huge sunshine and also a lot of cold. So this will create strong expansion stress, right, on the sides. So there are two possibilities. Either the parapets will crack under that pressure, not so dramatic, or the floor will bump, right? We saw both things happen. So that's the problem. The second point, which I think is more obvious in the science library, is that in the corners, you may have sunshine on one side, you may have shade and cold on the other. So one side is contracting, the other is expanding, and there's a lot of tension accumulated. So there is a very common accident of tiles and cracks happening in that corner. And this is because of the differential of tensions, of stresses. And this is why there is a tendency to make some kind of joints near the corners, right? So that tension does not expand so much to the border. So that tension in a, say, 20-meter wall is much larger than in just the 20 centimeters or just 1 meter, right? So the expansion, the contraction will be not so large. So you will try to make some joint even on both sides to absorb and to minimize this problem. Another interesting question, and we saw that in some of the flat roofs, why we have the parapet, we put the handrails as possible on the side, not on the top. I try to draw it again. If you put it on the top, you have a difficult joint you have to seal, and you have the water just hitting all the time. So this is a very weak point always, and the chances are that eventually it will leak. Think that also those handrails have a lot of stress, so they keep wind, people supporting them, so they keep moving, and this joint suffers a lot. If you do it on the wall, you already have some protection, right? And the water which is placed there is just a minimum fraction of what happens on the top. And besides, by doing it on the side, the chances of perforating some kind of a waterproofing is minimum. Whereas on the top, this cover element, right, is always a waterproof element. So this is why whenever we can, we cannot always, but whenever we can, if we have the choice, always making connections to the side. That applies for also for any other kind of elements, so like pipes or chimneys or so. If you have to have some ventilation, instead of putting the ventilation going through that element, you will go from one side, and you know that the joint of this pipe to the wall will be much safer than the connection of the pipe to the top of the wall. Okay, one more question, which I have to, let me see. So how do we choose each type of roof? Okay, so that's a big question. Often it is a requirement. So you may be in an area of one city which requires to have a flat roof, or requires to have a sloped roof to one slope, or which requires you to have a garden roof, as it happens now in Paris. So it depends on the regulations. Of course, on the climate. So if you make a flat roof in a place where you have a lot of snow, it is perfectly possible, but you have to have a provision on how that snow may be cleaned, because it will accumulate a lot, right? So usually if you have plenty of rain, you will also find a way of some roof which may be more efficient than others, right? So climate or places also it has to do with culture. So in many places, like it happens in Seoul, people expect to use the roof as additional space. So probably in that case, that choice is given by the needs of the client. But also it depends on your design, right? On the cost. Usually flat roofs are more simple, are cheaper. Sloped roofs are more complex, are more expensive, but they have other advantages. So there's many questions you may consider, right? And it is what design is about. So you have to see the problem you have, your choices, and then you choose whichever fits better the design. I will not read this. In previous years, this is 2 years ago, we tried to check in class the advantage of cool deck or inverted deck. I leave it in the sorry. This is you for read and to understand what people think and what we think is advantages or strong points of each of the different kinds of flat roofs. So I leave it for your information. And also we had interesting your replies I collected from advantages of green roof, which are a lot, and inconveniences, right, which are very clear. Actually, it's interesting, you read them and you may find more, right? So the advantages are huge, and this is why green roof is getting so popular in spite of those disadvantages, which are less than the advantages, but are strong, right? Especially about the weight, the complexity of construction, and the maintenance, and so on, right? So it's not easy to see. And curiously, many people say the insects were an inconvenience, but I didn't add here because we need insects to have our ecosystem working. So this is for your reference. I will not read it, you can do it. More comments about the sloped roofs. We are almost finishing this part, so we can have some time to review some things, but interesting. We have this talk of the slate roofs, and she asked, what happens, the water will not go through those layers and finally enter the timber. This is the principle of the triple layering and the slope. So the 3 layer plus the slope, right? That's the gravity working and the physics of the water. It's what we found out by experience of many centuries building. So if the slope is correct and you make the layering correct, the water has not time to go to the bottom part. Even so, we commented in the lectures, you can go back and see it. Insurance companies are obliging to have additional layer just in case. Because okay, when insurance companies are risking their money, they will try to be over redundant. That's okay. We said that if you put additional waterproof, it should be like a water. Actually, it's not totally waterproof, but let's say waterproof. Actually, it's water resistant. So that's thought to have just a few drops, not to have like a full first layer of waterproofing, but it should be steam permeable, just to keep the advantage of the ventilation. So the damp accumulated in the building could go out, and you have advantage of that ventilation, which is already previewed in the system. Otherwise, you lose a small advantage, and the building interior will have more difficulty to breathe, right? To get the steam out of it. Also, of course, concrete is quite tight, but still. We will try to have the minimum of possibilities of that, whatever dampness may remain in the walls, to be trapped by a very strong waterproof layer. This is why, when we can, we use some steam permeable elements. Economic advantages of sloped roofs. Well, we commented before, the basic flat roof is the cheapest, and usually very cheap construction. And you can see the apartments go to the flat roof, whatever. You may go to industrial metal roofs and may compete, because also they are cheap, they are fast to make, but usually they're not very flattering, they are noisy, they are ugly. So if you take care of that noise, those joints, and make it nice, that advantage will disappear. Of course, if you don't need a solid slab, but again, if you have a nice construction with a light metal roof, your sound insulation, the noise, and the performance on the element could be probably not what you expect. So if you avoid that slab of the top, right, one floor, and you have very light roof, maybe very cheap, but you have to work hard to achieve the comfort inside the room. Chilly sloped roofs are usually safer against leaks because always the gravity helps and the water does not stay a long time as it may happen in the flat roofs in which you may have water long time and it may eventually leak. And usually have less initial maintenance, right, and longer life because copper, stainless steel, slates last for probably ever, but the waterproofing materials have a shorter life. We can speak of 40 years, 50 years in a plastic, and that's great. In terms of the slates, we're speaking of hundreds of thousands of years. And with plastics and rubbers, we don't know, right? Especially, and we know polyurethane paint, for example, has a very, very short lifespan. You have to repaint again. So this is the differences. And again, knowing the material, the properties, advantages, and inconveniences are a basic knowledge you need to take a design decision in the end. This was interesting. Why so much complication in the roof detailing? I explained in class the slate roof, which is probably the most complex. Because if you understand the most complex case, then the simpler cases are easier, right, to understand. It's just simplifying layers, right? So in the case of a slate, we explained all the reasons why it is done like in this way, why the flashings are in this way, why the layering, why the battens and counter battens and the rafters are placed to have ventilation and all those things. We will not repeat. And we have examples in which we have just a continuous, probably paint, waterproof paint exterior. That is a perfectly okay solution, right? But you will have not all the advantages of ventilation. You have to work hard on how to make sure this dampness goes out of the building, that ventilation. And of course, you will have to be very precise in the construction, so you will have not cracks, which will compromise this performance. And you have to clean because the buildings just finished are very nice, but with time you will have the marks of water going down, right, depending on what is built, and you have to clean it. So being simple sometimes brings much more complication than using the usual complicated thing, because you are simplifying, you are removing many elements which usually are there for one reason. Okay, this is always one choice, right? And let me take. So the point is, there's not perfect solution. You always ask, what is incorrect about this? What is correct? And we cannot say something is totally incorrect or totally correct. There are details better than others, and there are choices which in some circumstances may make more sense than in others, right? So trying to fix the standards and having always the standard solution is good for organizing, but not for really the reality of designing, which you have to really adapt yourself to the specific case, right? So you have to be aware of the trade-offs, and you will have opinions, and as you work and your experience, you refine your details, as we usually all try to do. And well, some people speak why the activities and the exercises, the exams are also difficult, right? So I expect you to know many things, and this is depressing. I cannot concentrate. Okay, so in this case, during the lecture we do little, and the lectures are a bit different, but still, you know, this is a 5th year course, so some of you probably did not assume you're graduating, and what I have to expect from you in 5th year is not the same I expect in 2nd year. And so the evaluation and the way I treat the class is different, because I guess a more mature and more informed student has to be able to do something which very neophyte or very new student really needs to have more help, right, than more mature students. But still, Another interesting thing, how to learn details, right? Because they said, well, the books have details of old buildings and they're probably old-fashioned, and new details are hard to find because there's complete privacy and secrecy. This is a problem, right? That's true. It's not easy to find the current details. So how can we study detailing? So I think one misunderstanding is that horror for old-fashioned old buildings, because the physics and the principles are the same, right? So you need to understand the basics to then be creative, and if it is necessary, to innovate, right? But what is published is enough to understand the basics. So the basics are the same, just changes the technologies. You have to understand those basics from the books, right? You have to analyze the real buildings. The good thing, which goes any over copyright or secrecy, is that the buildings are there, you can see them, and you can look, and you will find a lot just by watching. And then innovating is totally changing our way of doing, which for that you need a lot of experience, a lot of trial and error, and a lot of experimenting. So that's a bit risky. You need to have a client which will accept also the clients of innovating or changing totally things. But without innovating, you can be always creative, right? That means just adapting that standard way of doing to your specific situation, specific case, right? And this kind of creative adaptation is something you have to do always. Almost never you will find the exact detail for your project. And that creativity is what will make your design really good and solid, because all the concept of the design goes down to the details. And many of the classical examples we see from Asplund, Kahn, Aalto, or even Mies van der Rohe, those details are really, really well connected with the general idea of the design. Those buildings will be totally different if you use totally standard industrialized elements, which are the same for any kind of building. So detailing is actually designing, right? And the design ends in the detail point. And that's not easy. You learn, it takes 5 years to have a basic it takes years to have a basic idea of designing, right? In general, so detailing is the same. It takes years, and actually, unfortunately, at school you have very, very little opportunity to exercise in this detailing. This is why the materials course and the building systems may be a bit overloaded. But this is what we have, and if you understand the importance of things, I try to give you as much information, much wide knowledge as I can, within which is reasonable. So you have at least the very, very basics. Actually, we cannot go beyond the basics here. So let's go into some exercises for helping with tomorrow test. I brought here the window detail. This was kind of very fast redraw, right, of the window. Of course, this is wood window. So please draw the windows details in a way that they are realistic. So this is clearly a window which opens on the right. The book makes a connection of the window to the sill, which I don't know why they do that. The usual way to fix the window is to the fabric or to the spandrel, right? Which is usually much more solid. I don't think, maybe I commented it, but okay, I don't know why the book has this connection, right? This is the usual way of fixing things. And then if the window opens on one side, make all your drippers in a way that will have space to move. I saw many of you who make examples in which those elements are just tightly connected, and that will make the window impossible to open. And of course, there are infinity of ways to solve this. This is just one example, right? See, for example, this commercial window. This opens to the inside. And this shows that those neoprene gaskets, right, can be very thin. So it can be just a 2mm gasket with the pressure that's enough. This is a sample, so you will not see that support element. That's not a real window. But you see how you have always gaskets in all 3 connections. So all 3 connection points have a very safe enclosure. And then the shape to have that unlikely but possible water coming in to go to the outside, right? With the timber, we need a minimum size, so it is strong enough to hold the glass. But we said if we have a, sorry, let me go back to the window. If we have steel, we will try to make this as small as possible. And all the additional space we need, we do in the back to the interior. So the water has the minimum possibility. But in the case of timber, PVC, aluminum, the materials are a bit weak, so we need a bit more space to have that strength. And again, there's a question of opinions. Whenever possible, one dripper will add a lot of safety to this point. So the problem is that drippers are ugly, in many opinions, and it's avoided. And then you try to have those fixtures helping with it. But if it doesn't disturb too much of your design, and you can, I would always advise to have a dripper, which really will change a lot the performance of the windows. And you see that the design is not totally the same, but the principles are mostly the same. And this is what is interesting of understanding the basics, right? The detail we saw from the book is very complex, but with that we can understand other elements and we can see the possible variations. And those variations are actually what are interesting for us to apply in our project, because we are creative, we are designing. Many people are disappearing from class. So this is one exercise I posted in Blackboard, and I said the solutions would be tonight. This is from one previous exam, and actually it was 10 points. So that means like 10 minutes to do it, right? We don't have okay, time to open the door, but nobody waiting. We have 15 minutes left. So probably we will not have time to make the exercises, but I put them here because I'm sure not everybody will go to Blackboard to make the exercises I posted there. But I want to do this together. This is a horizontal section of a curtain wall, right? And the question is, what are the mistakes? So have just 1 minute and look at it and see what do you think is not correct here. I can give you some hints. Well, probably try to see how many you can find. Gasket, yeah, the question is a gasket is a kind of a elastic strip, right, to use in joints by pressure. So it can be just like a small pipe of rubber. When you have 2 elements pressuring on it, it will just be compressed and it will be closed, right? You have gaskets with many different sizes to connect to change the shape, but they are strips, and you have a catalog, so they are industrially made. You can find them, right? And usually gaskets are rubber, but as I said, there are many polymers in the industry, so you may find. So if you go to window gaskets and curtain wall gaskets in Google, you will find a lot of industrially made materials there. Okay. So let's go to the detail, and if you looked around, we can see steel and aluminum together, which is something which probably we should check. We have a fixture which has plenty of space, which is perfectly okay, but again, we have steel with aluminum. And besides, this is something I see very often. Right, perfect. Many of you do this. How do you fit that screw, right? It is inside the pipe. Because you can say you make the pipe, and you perforate it, so from the side you can access the bolt and do it, right? But in that case, you are weakening the structural element, and you are making it difficult to construct, but then it should be expressed. So this is something which we have already the galvanic pair twice, right? We have one bolt which is impossible to make, and something we try to do, we know that the curtain walls need adjustments, right? In 3 axes, because we know the construction is not precise and curtain walls are precise. Here, adjustment is 0, so it cannot adjust in any way. You have not any gap with the concrete, so this is like a very rigid. There's not independence moment. It's very rigid, very bad detail. Right. So the galvanic pair we have in many parts and so on. So this is the points, right? Not adjustment, not flexibility, not independence of movement between the mullion and the slab. As we said, the fixture is having a galvanic pair, you cannot access it. And then this is so-so, right? Because again, you don't have almost any possibility of adjustment. The explanation is on the left. This is a question of curtain wall. Actually, usually this, well, yes, to add flexibility is what we commented in all previous. So the flexibility, the possibility to move around. So if you go to the curtain wall lecture, you see that we have between the slab and the mullion, we have a series of elements which allow you to adjust this space between, right? And often the joints are flexible, not always, but this is why we have the mullions have some kind of possibility of at least expanding in vertical in the longest direction. But go back to the Pirelli building, right? In which they have like the best example of that flexibility, right? And of course, yes. So those gaskets, the neoprene, again, the gaskets, right? But the detail was wrong from the beginning. So there's a really crazy way of doing. You can do that in a small construction, not in a really full building. In a small construction, temporary construction, you will not care so much because dimensions are very small, and you may simplify a lot, right? But it's not a good way of building. So again, usually the choice of the material is something more of a materials class, but it also helps exercising on finding the parts of the curtain wall. I put here the photo. This is very standard curtain wall. This is not famous architects, just from the handbook. The first thing we have to do in the details is to identify parts, right? So we see the slab. This is the spandrel, clearly, and the sea level, but was a spandrel. So we can assume that one part of this is going through the floor. The rest is windows, right? So it's probably next to spandrel, because we have a solid part, and this is the window, right? We can see the glass is easy, and actually we have only one layer of glass because we have insulation. We have double glazing. And then we have the important elements. The mullions will be projected on the back, so probably they will be consistent with those horizontal elements and so on. And then we can just find out which is the most appropriate material for each, which we have in the following slide, right? I'm going fast. Actually, I wanted to watch one by one with you, but actually you can check, and the choices here are actually very easy. A little bit tricky, but again, if you have 10 choices, right, that means 10 minutes. You have the easy ones, which you can see immediately, and then you may have some spare time for the more tricky ones, right? More tricky ones. The problem with the Blackboard system is that you have to reply one by one. But again, when you're sure, you reply fast, and you give yourself a bit more time in things which are difficult. The exam will have very, very easy, almost obvious questions, a little bit more tricky ones. Okay, so you have it here. You can have a look. So it's not really hard to see. This is another example, and again, which kind of curtain wall typology is it? So we can see concrete elements, right? We can see the slab with a big beam. We can see insulation inside. So we can see that the window is independent. So we can see there's heavy prefabricated panels, right? But they're not unitized because the windows are apart. Then to understand the elements very clearly, we can see the concrete, we can see the joints, we can see the slab, we can see some intermediate element and a very clear insulation side, right? The window is obvious, the dripper is obvious. Again, the dripper is repeated, right? You have a small drainage channel, which you can see even the channel here to collect the possible condensation and the possible leaks in the wall. You have the gaskets. So actually, you can see the insulation, the plasterboard inside, the suspended roof, the slab. So most of the questions are quite obvious. And then you have the elements, right? So heavy prefabrication, precast, reinforced concrete panel. And ignore this because that will be in the handout, not here. And you see that we have two kinds of insulation, right? So, and this is where the graphics are important. And I think the Blazers book is a bit confusing in that sense. So usually soft matte insulation is this kind of a wavy element, and rigid insulation is more like this kind of square elements to show the cells, right? So we have the rigid fiberglass or the polyurethane foam insulation, 25 millimeters. So in this case, this is fiberglass, and this is the polyurethane foam, right? Let's go. This is interesting because this is more. Let's go to the next case. This is more the kind of problems which are more the style for building systems. You have to think more. The finding mistakes is what we do usually, but I have to draw an incorrect drawing is quite incorrect detail is quite tricky. So we have again, as in the curtain wall, a roof, and the question is which kind of roof it is. This is a very easy question, and then which are the errors. There are some of them which are very, very eye-catching, right? This is the wrong size. You don't have expansion element. Now here, the waterproof is not sliding around, and so on. So the waterproof is under, the gasket should be covering. You don't have gaps in insulation in the pipe. So it's very easy to see the mistakes here. But don't think that it's easy, because these kind of errors, not all together, but some of them are very common in real life, and you have to be able to spot them fast. So if we go to so it's of course inverted and cool deck, and this is the problems we saw, which are at least 8 different misses in this, right? Including the insulation, which actually is, as what we said, should be waterproof, which I didn't comment. We have another case. So again, the questions are easy, and you will see it later, right? I'll let you to think about it, because actually we are almost ending the class. We're just 5 minutes from the end. This is a bit more tricky because you have the photo and the detail, and then I don't give choices. That's not the kind of question of the exam, but it's a very good exercise. The first part is very easy. If we see the details, so we have the flooring and then the garden, which is the other side. So this is kind of inverted view. But we can see the slope formation, kind of separation felt, insulation. Remember that it's very common to draw the insulation in yellow. From what we saw at the beginning, we can understand this four looks like a drainage layer, then another separation element, some kind of a drainage, again, felt, and then finally the planting part, right? In the other case, we have probably gravel and some cement mortar to fix the tiles and the tiles. Of course, we have to guess. This is why it's not exam question, but it is quite a nice exercise. So here you have the details as it is published, right? So you know what is really used. And this is what you saw also in the sloped roof. In this case, it's very easy to know what we have, and I gave the solution. So this is like a slope formation with those bricks which can go with the earth through. This is a slope based formed with the actually brick tiles. Then some leveling layer, usually is mortar. Then you have the buttons with the insulation, again in yellow. And instead of counter buttons, this is obviously some kind of boards, over which you have another felt, and finally the seamed elements. And probably if you look there, I might have almost all right. Maybe the one I said is a felt. It's kind of additional waterproofing. But again, this is like this is redundant. And mostly because of insurance, right? Not because of the need of the construction. And since we have to finish, let's go to the final test. So sorry, the details went a bit fast, but I wanted to do a lot of things. But for the exam, remember that most of the questions for practical elements, of course, there are questions about the theory and so on, but about details, they are mostly about finding misses, right? So you train your eye to see what is missing in some part. Okay, go to the test, and we have still 1 or 2 minutes to complete it. So make sure you reply all the questions, and I think the questions are easy enough, of course, depending the part of the class you missed. Please make sure you log in. I see still a few people who didn't start, and we have to finish on time. Still, if you have any last-minute question, I will try to reply and to post it in Blackboard, because I cannot join the lectures before the exam. Okay. Well, still some people did not start. Well, obviously some people didn't come to class today. Or some were late. Okay, I see that the majority has at least 2 replies correct. Please be fast, because I will close soon. Great. So I think it is time already. So it's already closed. So thank you so much, everybody, for attending today. And yes, of course, you can go out as you finish. There's not anything else, just saying goodbye, as I'm telling you. So goodbye and good luck tomorrow. Please try to wake up on time. And okay, I hope the best. Let's see you tomorrow.